All right, welcome to the continuation of the 2.8 video. So here we have a pebble dropped into a calm pool of water, causing ripples in the forms of concentric circles. So concentric circles means that they would have the same center. And it says the radius of the outer ripple is increasing at a constant rate of 1 foot per second. So dr dt is equal to 1 foot per second. When the radius is 4 feet, so to the outer radius, it's 4 feet, so r is 4. At what rate is the total area of the disturbed water changing? So we want to find dA dt. And we can find the area because remember we know area is pi r squared. But first let's define what our variables are here. We have r, which is the radius of the circle. And we have A, which is the area of the circle. So to find A here, we just take pi times 4 squared. So the area is equal to 16 pi square feet. All right, so now in order to solve this problem to find the rate, we have to take the derivative of the area formula. All right, so when we take the area here with respect to time, here we get dA dt, and here we get 2 pi r dr dt. So now we can substitute in what we know. We don't know what dA dt is, that's what we're trying to find. We know the radius is 4, and we know dr dt is 1. So when we solve this, we get 8 pi as the change in area. So basically, the change in area is 8 pi square feet per second. So you'd write your sentence, the change in the area of the disturbed water is 8 pi square feet per second. All right, the next problem is another one. So we have a passenger ship and an oil tanker that leave the port. So here's the port, right? Sometime in the morning, the former heading north, so the passenger ship heading north, and the oil tanker heading east. At noon, the passenger ship was 40 miles from the port and sailing at 30 miles per hour, while the oil tanker was 30 miles from port, sailing at 20 miles per hour. How fast was the distance between the two ships? And here's the distance, we'll call it S, changing at that time. So our goal here is to find ds dt. All right, so we'll let x be the distance from the port of the oil tanker. We'll let y be the distance from the port of the passenger ship, and then we'll let s be the distance between the two ships. Okay, so we know x is equal to 30. We know y is 40. We know dx dt is 20 miles per hour. And we know dy dt is 30 miles per hour. We can find s, because s, remember, is, we know s squared is equal to x squared plus y squared. So we know x squared is equal to 30 squared plus 40 squared. So that's going to give us that s is equal to 50, because it's a 3, 4, 5. So now to find ds dt, because remember that's what we're trying to find, we're going to take the derivative of the Pythagorean theorem here. So we'll take the derivative with respect to time. So we get 2s ds dt equals 2x dx dt plus 2y dy dt. So then you can substitute in what you know. So 2 times 50 times ds dt equals 2 times 30 times 20 plus 2 times 30 times 40. I switch those around, but so then when you solve, so basically we can divide by 100 here. So you get, so this would be 6, so basically you get 2 times 30 times 20 plus 2 times 30 times 40. That's 3,600 divided by 100. So that means 36. So that means that it's 36 miles per hour. So that means the distance between the two ships is changing at 36 miles per hour. All right, so that concludes our video for 2.8. Have a good evening.